This is a follow me video for the bouncing ball project. In this project, you'll implement your own classes, your own types of things. You've been using classes all along, as for example with Rose Graphics, the circle class, the rectangle class, the Rose window class. Now you're going to learn how to implement classes that you design. For example, you'll do a ball class here. In the usual way, go off to wherever it is that you get the starting code from. Notice, however, that there are 3 videos to watch before this follow me video. 3 videos that you watch before that give the ideas to the concepts, the notation, and then the implementation of a class. So that's background knowledge, which you'll then apply in this follow me video. A total of 3 videos totaling 27 minutes. After you've watched those, then continue with this video. Accept the assignment in the usual way. Go ahead and copy the link in the usual way and then clone it into PyCharm, again in the usual way. Once you put it into PyCharm, you'll attach it as usual to get it to your other things. Once you're in there, you'll see that there are 2 folders, a solution folder, no peeking, and a source folder. So the solution is there for you for your reference afterwards, but and it does have a solution there. And I want to run that solution first, but don't look at the code yourself. Don't look at the solution. Just observe what happens when we run it. Well, we get this project here where there are all sorts of balls and they bounce around. Now, what is the obvious type of thing, the obvious object for which there are multiple instances here? Think about it. Pause the video if you need to. And I hope you've decided that what there are balls, and so we'll make a ball class. So that's where we're about to go. SRC folder, not the solution folder, but the SRC folder, and open the M1 file that is in there. Make sure that you're looking at the M1 bouncing ball file, not the M1 bouncing ball solution file. So the one that's in the source folder. As you see, it has a bunch of to-dos, and we're just going to work through it by working through those to-dos one by one. I'll pause the video. I'll ask you to pause the video at various points to both write some code and do some thinking, but then you can follow along with me. Start by putting your name there. So go ahead and put your name in there as I'm doing. Pause the video as needed. And then we've already done step 0 here, run the supplied solution. And to design the obvious class, well, we've started to do so. We haven't done what are its methods or its instance variables. Project looked like, it's a still image of it, but just imagine that these balls are moving. What the obvious class, the obvious type of thing is a ball class. Each ball has actions it can take, things it can do. Those form what's called its methods. What are the methods of a ball? What can each ball do? Think it through. And I hope you see that each ball can move and perhaps bounce. Also, each ball can be drawn, so there'll be a draw method. And each ball needs some way to initialize its characteristics, so an init method. What data is associated with each ball? Each ball has what? Think about it. I hope you see that each ball has a color, an X and a Y coordinate for its position, a radius, good, and perhaps a speed, and then other things that we'll see, but those are the main things. The next step, again labeled step 0, is to read and absorb the starting code, all of which is standard for any Pygame project. So you've seen all this in previous projects. You import Pygame, import sys. You haven't seen that there are these notion of global variables, 3 variables there. They're global to the file. That's an error-prone practice, but we'll use them sparingly. we always use all caps for their names so that we don't have any name conflicts. There's main and the call to main at the bottom. At the beginning of main, we initialize Pygame. We set the mode. We make a screen, the relevant side with the set mode method. And then we set the caption and make a clock. Then each time through the game loop, so over and over again, 60 times a second, we tick the clock, and then we get the events that have occurred. Here, that means just the quit event, so when the user presses the quit. And then we have the do every cycle activities and the draw everything activity. For every cycle action, what is going to happen each time through the game loop? Take a moment to think about that. What happens over and over again? And I hope you decide that the balls move and perhaps bounce. That's what's going to go in the every cycle actions. And then in the drawing, each time through the loop, we'll draw all the balls. So each ball will get moved in the every cycle actions. Each ball will get drawn in the draw everything section. That concludes the review of the standard starting code. If any of that is unfamiliar to you, you should go back to previous projects and see how it does in the previous projects. So we've read and absorbed the starting code. Now we're going to implement a ball class with what's called stubs for its methods, init, move, and draw. And we'll also construct a single ball as part of that. To make the ball class, we put it in its own file. So we want to make a Python file. So you right-click on SRC, choose New Python File, and then what pops up, you type ball with a capital B. Ball with a capital B. Make sure it's a Python file. Again, that was right-clicking on SRC and then New Python File. Choose the Add option. If you missed that, you'll get a chance to do that when you commit and push. So here's our empty ball class. I'm going to move it over here so that it's off to the right so we can see both at once and fix up my screen so they look pretty. The existing M1 bouncing ball class, file, which had that starting code, and this new ball file that will contain our ball class. You start by just saying class and then the name of the class, ball. And it then, on the next line, offers to fill in for you a method called __init __. We'll also make a method called move. They each take as argument self, and we'll have each method have pass as its body. Pass is just a placeholder that says do nothing, do nothing. Now it's very easy to misspell init in these stubs, to have the wrong number of underscores or to forget the I there. So make sure you have __init __, paren self in all cases. Then back in the bouncing ball file, at the top there, we have to say from the ball file, import the ball class. So a different form of import. And then here in main, we're going to construct a ball in the usual way by just saying ball1 equals and then the name of the class, ball. No RG dot because it's not in Rose Graphics. And we don't need to say ball dot because of that notation from ball import ball. So ball is available to us. Note how that when we construct the ball up there in the ball class, we put nothing in the parentheses, but when we in the init method, there's the word self in the parentheses. Self is the ball being constructed, the one about to be called ball1. So we put self in the parentheses in the definition of init, but we put nothing in the parentheses when we construct the ball. So self is implicit. So we've now constructed a ball. Before we're going to tell that ball to move, so we just say ball1.move. Again, self is implicit. Self is the object in front of the dot for all methods other than init. So ball1 is moving there, and ball1 is what we're going to draw. So type along with me if you haven't already. Ball1.draw there. Pause the video as needed to make sure that you've caught up with me. that you over there in the ball class made those three methods, def underscore underscore init underscore underscore, with self as the sole argument, pass as the body, move and draw likewise, and that back in main you constructed a ball called ball1 and you said to ball1 equal ball paren paren, and then further down in main you told ball1 to move and ball1 to draw itself. Then go ahead and run the program in the usual way, right-clicking in the M1 file and selecting Run. Be sure that you run M1 bouncing ball and not ball, so right-click in the M1 bouncing ball to run M1 bouncing ball, because that's where main is. It should bring up a blank screen as shown here. If you have any troubles, pause the video, look back and see what you've made, where you've made any error. Close the project when you're ready. Since move and draw do nothing, there's no balls showing up yet. So again, there were methods init. Oh, the most common error is to misspell init, underscore underscore init underscore underscore. So make sure you got that correct. But if yours shows up, you're probably okay. So we've now implemented a ball class with stubs, what's called stubs for each thing. And now we're ready to, and we've constructed a single ball, and now we're going to make it appear on the screen. Which method is for that? I hope you decide that it's the draw method. And to draw it, we just need to draw a circle. And perhaps you'll remember that you then say Pygame, what module? The draw module. What method? The circle method. And if we hover over the thing, it both pops up and then shows more legibly the documentation. We see we need a surface, a color, a center position of the ball, and a radius. The remaining things are optional and we won't need them for drawing our circles. Surface, color, center, radius. So the first thing we need is the screen. Now, if we just put screen here, that makes no sense because there is no variable screen over here in the ball class. What we need is somehow to get the screen from where it was constructed over there in main, in the M1 bouncing ball file over in main. We need to get it to the construction of the ball. So we put an argument there inside the constructor and an instance variable screen for the init. So now init takes two parameters, a self, which is the ball being constructed, and screen, which is the screen. And what we do is we then say, and you'll see it coming up here in the code in a moment, in the video in a moment, we put self.screen equals screen. I'm gotten a little ahead of myself here. We'll see it here in the video in a sec. Meanwhile, here I'm defining self.color to be black, 255, 255, 255. We also need a position, so we need a self.x and a self.y. And we're going to shortly need, so here's self.x being set, I'll arbitrarily set it to 100 for now, and self.y I'll arbitrarily set to 100, and then I'll pick up what I meant to put earlier, self.screen equals screen. So that really should be the first one there. So we're storing inside self, inside the ball, this data, the screen, the ball's color, the ball's X, the ball's Y. We'll also do the ball's radius here in just a moment. And then when we draw the circle, we draw it on the screen with its color, with its at its position, at its XY. Notice that the position is inside parentheses, paren self X, comma, self Y, close paren. So the position is inside parentheses there. See it coming along here. And then after that, we put self.radius, which we've yet to make a self variable for. Again, self is the ball. Self.stuff are the things that it needs to is the data that's associated with the ball. So we have the ball having a screen, a color, an X, a Y, and now a radius, which I'll initialize to I think 20 or so in 30. I'll do 30 as my initialization. So we now have the draw method done, and it should be that when we run, it oh, by the way, that reformat code there was to just clean up my code, make sure that I'm formatting it correctly. You can do that at the end, but I thought I would do it right there just to show it to you. And also sometimes that exposes errors when you misalign things. So there we are, and there's our white ball. I said it was black, but it's really white. 255, 255, 255. All red, green, green, and blue. So we've now made the ball appear on the screen. If you have any questions about that, pause the video at this point and look at that, what code we put over there in the init and in the draw method. Now we're going to make it move and then bounce. So here's move, and so we're going to implement move. Move means to change what variable? What instance variable should change to make it move? Remember, we're drawing it at x and y, self.x and self.y. So if we reassign self.x and self.y each time through the game loop, that will have the effect of moving it. Now we're going to have it move per speed, and so I'm going to make a speed in the x direction, which I'll initialize to 3, and a speed in the y direction, which I'll initialize to, I think I'll make it a negative number, -5 or something in a moment here. Let's see here, yes, -5. And then over here, we can say self-x plus equal self-x speed, and self-y plus equal self-y speed. So that's self-x equals self-x plus the speed. It moves it by the speed. So we should now see, when we run this here, that the effective move is to move it by the speed, and we should see the ball move. Let's see what happens when we run again. And so we see it runs pretty fast there. That was a little faster than I want, so I think I'm going to change my speed a little bit and make the y speed be -1 or something. We'll see what I'll change it to here. -1, yes, little, so that I can see it. If yours doesn't show up, or if you have any errors, pause the video now and check to be sure that you did the move method correctly, and that you added that radius, x speed, and y speed there, and that you spelled all those variables correctly. So we've now made the ball appear, we've made it move, and we're ready to make it bounce. Oh, bouncing. Bouncing means if it hits the left edge, change the speed to be going from toward the left to go to the right. If it hits the right edge, make the speed go negative what it was. That's the effect. Is self-bouncing makes it move to the opposite direction in the x and or y coordinate, depending on which wall it's bouncing off of. Now I'm going to make a helper method for that, self-bounce if off screen, just to isolate the bouncing code in a method of its own naming. So move will call this helper method, bounce if off screen, and my ifs I'm going to put in the bounce if off screen. That way, if ever I wanted to change my bouncing behavior, as I might, to make it smoother bouncing, if ever I want to change that, I have a method just for that. So it's when you find that your code is breaking naturally into parts, make helper methods as needed. So if we're off the left edge, if the x is less than 0, or we're off the right edge, self.x is bigger than the screen's width. Notice the parentheses in the get width there. Now, it may not have popped up get width for you, so watch carefully. I'll talk about that in just a sec, but watch carefully that you get self.screen.getWidth paren. I'm going to make it so the pop-up help works better in just a moment. If that's the case, we're going to change self-x speed to the negative of what it currently is. Not minus equal, but equals minus. So instead of going to the right, it will go to the left, or instead of going to the left, it'll go to the right. And then we do similarly with y. If it's less than 0 or self-y is bigger than the screen's height, then we want to fix it off to the right there. By making y change to its speed. So let's see here. With hindsight, I'm unexcited about having chosen x speed as the instance variable name. I wish I'd called it speed_x to isolate the x more. So I could just save x speed to the dictionary if I wanted, and it would stop objecting to it there. I did just change that. I just changed it so that it no longer thinks of X speed as being misspelled. I'm going to go ahead and run it, and it is indeed bouncing. So if your code doesn't bounce, pause the video and back up the video as needed so you can see whether yours is working right. Notice that it's bouncing based on the center of the ball. We could make it bounce based on the edge of the ball with a little more care, but I'm not going to bother in this exercise. So we've now implemented move and bounce and draw and tested them, and we're ready to move on to the next item in the thing here. We've made the ball appear, we've made it move, made it bounce, and we're going to construct 2 ball instances instead of the current one. So we're going to construct a second one. Initially they'll be on top of each other, but then they'll be at a random place, a random color, and a random speed. So each ball will be at a random place, a random color, with a random speed. So let's make a second ball, ball 2. It's equal to ball just as before with the screen, which it needs. And if we were to run now, I think that's what we'll do here, is go ahead and run. Oh, we got to make ball 2 move and ball 2 to be drawn. Pause the video as needed if you're falling behind in the typing. And now we can run, and we should see that there are 2 balls, but we won't be able to tell them apart because they're right on top of each other. So when we run here, we'll see what looks the same as before, but in fact there are 2 balls, one on top of the other, and both of them are white, so they just look the same. Now what we want to do now is to make each ball have to appear at a random place on the screen, So we want self X and self Y, instead of starting at 100, 100, to start at random positions. We'll use the random module for that. So we're going to import random up top there, and we're going to do random dot. Well, let's import random so the dot trick will work for us. And so we do random dot, and there are various functions to get random numbers. There's random, which gives you a number between 0 and 1, randint, which gives you an integer in a range, and randrange, which also gives you an integer, but in a slightly different range. So random between 0 and 1, randint for a random integer, randrange is similar to randint. We're going to use randint, and so we'll make it be randomly between 0, the left edge for the x-coordinate, and the screen's right edge. Now when I do self.screen dot, it shows get width and get height because I've typed them before, but I'm making a mistake now. I'm making a mistake, so stop typing here if you're typing with me. I've just made a mistake. I'll correct that mistake in a moment. But random randint, I need those parentheses after get width and get height. But they aren't showing up in the pop-up help, and that's because PyCharm doesn't know that screen is a Pygame surface. So the way we tell it that is in a strange-looking notation, but it's very helpful. After the word screen, at the end of the word screen, not the beginning like I started, but at the end, we put a colon, and then we put the type of thing it is, which is a Pygame.surface. Pygame.surface. And somewhere along the line, by the way, it imported pygame.draw. We're going to fix that to just be import pygame at line 1 eventually, but it's fine there. If you haven't had an import of pygame, be sure that you have that there at line 1. But now the dot trick works, and so we can do, if we backspace over the get height and get width and retype the dot, now it shows get height as a method and will type the parentheses for us. -1 because the numbering starts at 0, and so the biggest y can be is the height -1. Equal to the height is off the edge. So here's our 2 balls, and they do indeed march along. They march in lockstep because they have the same speed, but they're at random different places. If we are running again, they'll be at 2 different places for starting. And so we've now implemented the start at a random position. Again, if you need to stop the video as needed, if you're falling behind, and rewind the video as needed to fix any errors that you might have. So there we are, rand int. We used screen and we called it a surface. We've implemented move, we've implemented bounce if off screen, and we've implemented draw. We're now ready to go to the next item there, a random color. So that's the self.color up there, which is currently set to 255, 255, 255. So we're going to make it, in parentheses, random.randInt between 0 and 255. And randInt goes between 0 up to and including the 255. So there's the randints, and now we have a random color. We can run and see how that works. Here we are running. And indeed the colors are random there. So there, now the two balls have random starting point and random colors. Just pause the video as needed if you're having any troubles. Again, line 1 might say import Pygame for you, and that's what it should end up. Mine has temporarily decided to put Pygame.draw up top there, but it really should be import Pygame. I'll fix that later in the video. Now we're going to do a random radius within some range where the range is specified as parameters to init. So we're going to add to init two parameters, a minimum radius and a maximum radius, and we're going to set the radius to be some random number between the minimum and the maximum. So we're adding two more parameters there, min radius and max radius. And instead of setting radius to 30, we're going to change it to a random randint between min radius and max radius. So it's now the case that we have random numbers for the radius. Now, there's a problem, though. We've just added two more parameters, and so when we run, it's going to crash saying that there isn't a min radius and a max radius value established in main. In main, there's no we haven't established the values for the min radius and the max radius. We'll do that by using what's called optional parameters with this equal sign notation here. We'll set min radius as an optional variable with default value 5 and max radius an optional variable with default value 40. And now when we run, the ball will be somewhere between 5 and 40 in radius. So we have two different balls there, randomly chosen between 5 and 40 as their radius. This one here, I think this just must be a very teeny ball. I'm not quite sure why there's only one showing. I think it must be very small. I guess I don't quite believe that. Min radius should be 5. I'm not sure why it didn't show up there. I'm looking at the code to see, but I think the code is fine. Not quite sure why we didn't see that one. Maybe 5 is such a small number that it's invisible. Oh yes, look, 5 could be, who knows what that one is, but it's pretty teeny. So I better change that min radius to be something bigger than 5. I'll change it to 10. And so there we go. So I changed the default value for min radius to 10. And let's let you catch up here. Make sure that when you run, so go ahead and run if you haven't already, go ahead and run and make sure that it still runs successfully. I'll leave the video up for just a moment here so that you could pause it easily here if you have any troubles. Again, there was a min radius and a max radius, and we used default values for them. Now, because we used default values for the min radius and max radius, over there in main, when we constructed ball 1 and ball 2, we didn't need to say what their min radius and max radius are. It just used the defaults there of 10 and 40. But let's go back to main now and see where we constructed ball 1 and ball 2. And we're going to put in values for our radii. Now we'll leave ball 1 as the defaults, but for ball 2 I want to set the max radius. I could just put 2 numbers there. I'll show you that in a moment. But for now, what I want to do is to set the max radius. I could just put 2 numbers. That's what's actually popped up right there. But I think I'm going to change that in just a moment here. Let's see here. We'll do ball 3. And so I'm going to throw away ball 3, so don't bother typing it. Don't bother typing ball 3. Let's go back and I'm going to fix ball 2. No, I'm going to type in ball 3. So ball 3 shows you how you could have just 3 items there, screen and then a number for the min radius and for the max radius. No, sorry. Ball 2 shows you 2 numbers. Ball 3 shows you that if you want to establish max radius but not min radius, use this odd-looking notation, max radius equal 30 there in the call. We'll come back and see that again later. So we've now done a random place, random color, random radius. You should run at this point and make sure that it worked successfully, those changes that I've just flashed past. Now we're going to do a random speed. For doing a random speed, it'll be similar to the way we did the radius. We'll just have a min speed and a max speed. We'll use one variable speed, min speed, mean max speed, 2 variables, one for each, min and max. We'll use them for both x and y directions. So random speed within a random range, a specified range. So there's min speed and a max speed, and I'll set some default values for them in just a sec here. Let's see, I think I'll use min speed as 1, the smallest speed it could be, and although we could use fractional numbers here, I suppose. And max speed I'll set to, I think 8 or so, which is a modest speed. So by default, it's 1 for the min, max is 8. Now for speeds, so I'm going to now change those 3 and 1. For speeds, I want to allow fractional values for speeds, so that it could move at a distance of 3.2 in one direction and 4.1 in another direction. So I've got my min and max there, but I need to change the speeds. And my basic formula is going to be per the following here. So let's watch what comes up here. I want to take the min speed plus some fraction of the range from the min speed to the max speed. So, and then having done that, I want to multiply it by a direction, a -1 or +1, so that I can go either way. So I've got the minimum speed, let's say that's 8, plus, let's say we're going from 8 to 12, that's a range of 4, some random fraction of 4 added to the 8, and then plus or minus 1. That's what we're after. So I'm going to comment that out there so we can stare at it, that pseudo code, while we're developing the code. Now I'm going to right-click on the word xspeed, which I'm dissatisfied with, and refactor, and then choose rename below there to rename xspeed, which I wish I had named speed_x, just style. But the way I do that is I put in there, select current file, make sure you do current file for the scope, and then refactor. I'll do it again for the y so that you can see. So I'm going to right-click on Y speed. Oh, and notice how it changed all the X speeds to speed X's. Right-click on Y speed, refactor, and then up the top there, rename. And then type in X speed, speed Y rather, and then select the current file, and then refactor. So that's a good way to, we call it refactoring, to improve the code as you're going. So I'll just give you that as an example. In any case, end up so that you have all those words being speed X and speed_Y so you match the video. So what we want is to match this pseudocode that we've got there. So we want the min speed plus a fraction of the range. So the X speed, let's get the fraction of the range part. So the amount above the min, we'll call it. It should be a random dot random, that's a number between 0 and 1, times the range. So it's a fraction of the range. So times the max speed minus min speed. So if the max speed were 8, if min speed were 4 and max speed were 12, the range is 8. That would give us a random number times 8 that we're going to add to the min speed. So the speed x is the min speed plus that amount above min. And then we also need to get the direction involved, so times direction. So we'll take that entire expression and multiply it by a random number that should be either 1 or minus 1. Now the way we get random numbers that are either 1 or minus 1, so we're going to do that there. Take that and multiply it by, let's get our direction in there. So here's an x direction, and it's going to be a random dot choice. Choice gives us choices, and we put either in parentheses or in square brackets, a sequence either way, minus 1 and 1. So it chooses between minus 1 and 1, equally likely for each. And then we can take our min speed plus amount above min and then multiply that entire expression by the x direction. So it'll be either going in the positive direction or the negative direction, to the right or to the left. You can now get rid of that pseudocode and replace it by, since we now replaced it by actual code. Again, what we had there was the min plus a fraction of the range. So we're going to test out that part there, and it looks like it's working so right for the x direction there. They both were different than each other. Now we're going to do the y speed in a similar way. So we're going to do the y speed in a similar way. Again, the approach here is we pick a random direction, minus 1 or plus 1, multiply that by an amount above min added to the min, where the amount above min is a fraction, a random fraction between 0 and 1 of the range max speed minus min speed. While I'm at it, I'll clean up my names using y direction, y amount above min for the y's and x's for the local variables there with the x things. So just stylistic changes there. Make sure that you end up with consistent things. Make sure yours works, and then compare to this screen as needed to fix any errors you might have had, any typos. Whoops. Apparently yes, there we are. I made a typo there. Speed y. So make sure you catch that there. Speed y throughout the y's. Speed x for the x's, speed y for the y's. So there I'm running it, making sure that it's all running fine, both in the x and the y direction. It seems to be random speeds. So I think we've got that part there. So we've made it so that we can have the ball do all the things it's supposed to do, moving, bouncing, drawing. We've got our random position, random radius, random color, and random speed. Now we're ready to make a list of, say, 100 ball instances. I'm actually going to make 10 ball instances, I think. But the list of 10 or 100 ball instances and do it that way. Also make the screen bigger. So we'll do that while we're at it here with making it up to 650. So here we are with our 2 balls, the current run. And we've just changed our screen size to 1000 by 650, so it's bigger. Now we're ready to add, in addition to our ball 1, ball 2, and our fake ball 3, we're going to add a bunch of balls. We're going to build up a list. Remember the build up the list pattern? Think a little bit about what to be typing here. Yes, you start with the list of balls that is empty, and then we're gonna add in the code here is going to do 100, but you should do 10. Do 10 balls, not 100 like the video shows. Do 10, and then you take and make inside the loop. You make a ball. We'll make a ball, and we'll just use the default values, I think, for the ball here. So ball equal ball paren, or screen paren. And then we'll take the balls list and append to it that ball that was just constructed. Append is better than the plus approach. Could have written balls equal balls plus square bracket balls, close square bracket, but append is a more efficient version applicable to lists. Doesn't work for strings, but works for lists. And then down there in the move and draw, we just loop through our balls list in the usual way to move all the balls and draw all the balls. Notice how the dots will appear here. So we say balls bracket K dot and then move. So the dot is after the bracket K, of course. And then similarly here, a loop for the drawing. So we had some code up there where we constructed a list of balls. We loop through that list, moving each one, and we loop through that list, drawing each one. And then we'll have, in your case 10, in my case 100, extra balls on the screen. So let's go ahead and run and try that out. By the way, I should have been using the green arrow all along. That works nicely when you have multiple files, because you always want to run the same file, in this case the M1. So there they are. Like I say, I have 100. You should probably do better to do just 10 at this point. And they seem to be random to me. So I think we're good. Now the next thing in the to-dos, let's go on up there and check those to-dos, get the windows set up again. So again, just want to show you again what we did there. So the loop with making the balls, the loop moving the balls, and the loop drawing the balls. So make sure you have all that there. If you had any troubles there they are for you to look. Next thing is to make a balls class. So we just did the 10 or 100 ball instances. Now, rather than have lists of balls, it's convenient to make a balls, plural, class, and then the balls class has all that looping code inside it. So instead of having, if we want, for example, 25 slow big balls and 75 fast small ball instances, we can make one balls object that contains one type of ball objects and another that contains a different type of ball objects. And so we'll make a balls, plural, class. That'll give us more practice at making classes, and you'll see that when you get to your project, that's a handy idea. If you have multiple instances of some object, it's often happy to have a class for the instances rather than making and the class will contain a list of the instances, and then you can have the class contain all the looping code instead of having to repeat the looping code every time you make different instances of the class. So anyhow, here we are, right-clicking on SRC, balls, plural, with a capital B. Right-clicked on SRC, new Python file, add it to the list. If you forgot to add, you can add it in later. And then we're going to go up here and make let's see, I guess we'll make a class called balls. So they're in the ball class, somewhere along the line, I got pygame.draw in there, and it really should have been pygame all along. Just import pygame. So at some point there was the optimizer put in a .draw there for me because I was only at that point using the .draw. But anyhow, it should say import pygame. You might check that yours says that in the ball class. So here we are importing pygame again, doing the balls class, plural. And then we have a class and then balls. And then we have our underscore init underscore method. And we'll make stubs for starters. We'll want to have an init, a move, and the draw. And the idea is going to be that in init, we're going to make a list of ball objects, and then we'll loop through and move them all and loop through and draw on them all. Sort of like we just did, but now making it into a class. We want, let's see here. Oh, so we have to put in from balls, import balls into our main. So that's back in main there. And then down below, we're going to create a balls instance. So below our creating balls, we'll make some two different kinds of balls. Let's run to be sure that our stubs didn't break anything, and they didn't. Okay, I'm just going to fix up my windows. In the video, I skipped a little bit here, but there's the ball class, the balls class, and then main. So I've just rearranged my windows here so that we can see all the things. In the balls class, well, balls are going to need to have a list of balls. That's the key idea, is that they have a list of balls. It'll start out empty, and it needs to be stored in self so that we can loop through that list in moving and drawing. Now, in addition, we need the balls to have the screen because we're going to pass along the screen when we construct a ball. It's a Pygame surface, That'll make the dot trick work better for us. We also need, I'll make it more visible here in just a minute, a min radius and a max radius. And we'll use this in a min speed and a max speed. So, and I'll use the same defaults that I used in the ball class. And so, just as for the same reasons that we had these variables in the ball class, we'll have them in the balls class, so that the balls class can make a collection of balls of a kind of radius size and a kind of speed size. And then we also need to say how many balls there are. Let's get our defaults in here right first. Same defaults as with the other one is what I'll choose. Could have made them different, but I'll choose to use the same defaults. And then, let's see. So take a moment to see that you're with me here. Now, the other thing we need is the number of balls. So the balls class needs to, first of all, needs to store the screen. So I'm going to put that there as the first line of my code there. And then I'm going to have my list of balls. It starts out empty, and we're going to have a parameter, an argument, for the number of balls. We're also going to store here we go, writing that loop there for k in range, and then we need the number of balls. So we'll need a variable for that, another argument, number of balls. And we don't need to store the number because our list is going to be as big as that, going to contain that many balls in it. So we're building up that list of balls, number of balls of them. And so we're just as before, as we did a moment ago. We'll make a ball. We'll use the pass along the min radius, max radius, and so forth that was here. So whatever, we can either use defaults or not as we choose, but we'll just pass them along to the ball class. And let's see, it doesn't know about ball yet, so we're going to have a from ball import ball. And having constructed that ball, then we can put it into our list. So we just looped through, made a bunch of ball objects. Let's just run right now to make sure we didn't break anything. And yes, there we are. Haven't finished what we were in the middle of, but just wanted to make sure we didn't break code. And then we're going to put into the list of balls, we're going to append that ball, just like we did before, but now we're encapsulating, is the word people use, that looping code through a list of balls into a class. And again, that's convenient because we can then make collections of different kinds of balls, different balls objects, and it's also convenient because it isolates the code that does the looping. So here's our loop that is similar to what we just wrote. I'm going to use a different form here. For ball in self.list of balls, ball.move. This is an alternative notation you can use when you don't need the index variable. And so it's just a syntactic sugar, they call it. It's just a more pleasant way to write it when you're looping through lists and don't need the index variables. So you can contrast it with the way it was done over there, where we used a loop variable, balls bracket k. This is equivalent. It just is more elegant to write it this way. So you can write it this way or not as you choose. Some problems you have to have the other form because you need the loop variable in some problems, but not here. So I'm going to run and make sure I haven't broken anything. Haven't made any balls instances yet, so I don't have the slow, fast, the various balls of the various types yet. I still have it 100 there because I made 100 when I made the video. I hope you have just 10. Makes it easier for you to see. So I think the next thing is that we need to go back to main in the M1 bouncing ball file, and below making that balls variable, we're going to make a variable for slow big balls and another one for fast smaller balls. 25, we're going to make 25 slow big ones, 75 fast small ones. So we're going to create a balls instance here, and we'll need to pass along the screen, and we want them to be 25 of them, so that's the first thing there. Number of balls will be 25. So we need the screen and then the number of balls and then our optional values for the radius and stuff. Now we want big balls, so our radius are going to be pretty big. Now in making the video, I just cut away to this screen where I've isolated the file that we're typing in. So here's the M1 bouncing ball file with main, and we're in the process of making our slow balls. So we have balls, 25 of them. For the radii, we'll have it range between 15 and 40, thus be pretty big. For speeds, we'll have it range from, well, we'll just set the max speed to be 4, and that makes them slow. Actually, I think I'll use maximum size of 50 for the radii, make them a little bigger there. So 25 balls ranging from 15 radius to 50 radius, max speed 4. For the fast balls, I'll make a bunch of balls. They'll be on the screen. I think I want 75 of those, if I remember right. Yes, 75 fast but small balls. So 75 here. And we want them to be small, so let's set the min radius. Let's see, we want them small, so we'll just set the max radius of 12 we'll use. And then we want them to be fast, so we'll set the min speed and say that they're at least 3 as their speed, and we'll use the default for the max. Actually, let's use min speed of 5 and max of 25. We'll let them be really fast. Let's run to be sure we didn't break anything. Nothing visually will be different yet because we haven't told the various balls instances to move or draw. So you'll still see, in your case, just 10 there. So now let's go on down a bit, having made those, and tell the slow balls that they need to move. And you can see how it's now just a one-liner where it used to be a loop. It's not a big deal, but it's more elegant to do it this approach, where we make a bunch of small balls with, instead of having to loop through them, we just tell them collectively to move. Likewise, instead of having to loop through them, we just tell them collectively to draw. And then the collective draw, does the looping. So it isolates the looping in the balls class. So now when we run, we'll see those 25 slow balls and 75 fast balls show up, in addition to, in your case, the 10 that you had. I originally had 100, and now I've added a second 100. In your case, you originally had 10 plus the 2 individual balls, and then you've now added 100 more. And so you should test, make sure that they're running, make sure that when you run it again, they look like you have indeed some big slow balls and some fast smaller balls. So I think that other than the optional part, that completes our exercise. Let's go back up there and take a look at the to-dos. Yes, we've now made the balls class. There's an optional step, which I'll leave to you to do if you wish, but I won't put it here in the solution. It's a good exercise, though, so if you want additional practice on using instances of classes and writing classes, making a scoreboard is an excellent exercise. Let's just review what we've got. Here's the ball class, so I'm just reviewing what you've done today. There's the complete ball init for the ball class. Take a moment to, if you had any troubles, here it is that you can look at to see the final solution. And there's move and bounce if off screen. And I didn't show you draw, but there it was. Here's main with the balls being constructed and then being moved and later drawn. Just reviewing what we've done here. And then we made the balls class plural. Let's see if I'm going to show that here. Yes, back to the ball class, showing, not sure what here, showing init again with the ball class, and then move, and then bounce if off screen, and then draw. So just summarizing here. Notice that balls have a screen color, X, Y, and radius. And then 2 methods, move and draw, as well as a helper method, bounce if off screen. We chose to make that helper method to isolate those if statements. And then we made a balls plural class where you specify an instance of that has the screen, but also the number of balls and the range for the radius and range for the speed. And then we constructed there a list of balls, put into the list however many ball instances were needed of the relevant type. Oh, there's an improvement, by the way. We don't really need to store the screen as an instance variable here because we don't use it. We use it inside the ball class, so it needs to be passed along to the ball class, but it doesn't need to be stored with the balls plural class. So a little improvement there. You can make that improvement if you like. So again, that was to change self.screen to screen and to get rid of the self.screen itself. So there was making our list of balls, and then we looped through and moved them, and then we looped through and drew them. And then just to review the bouncing ball itself, where main was, we imported the ball and balls classes using this from file name import class name style. We made a couple of instances of balls, one of which, each of which we used optional parameters. And we made a list of balls explicitly, and then 2 balls instances, fast slow ones, slow big ones, and fast small ones. We told all the balls, all 112 in your case, of the balls to be moved and then to draw. And that concludes the project. If you have questions, please follow up by asking your instructor to explain things. This is an important exercise that shows you how you implement a class, and you'll do lots of work like this in your project.